Buchanan, Chair of the Day, and I'd like to welcome aboard our speaker of the day, Greg Wrightstone. Mr. Wrightstone is a geologist with more than 35 years of experience researching and studying various aspects of earth science. He earned a bachelor's degree from Waynesburg University and a master's from West Virginia University, both in the field of geology. He was recently accepted as an expert reviewer for the UN's Intergovernmental Panel on Climate Change. His book, Inconvenient Facts, is the #1 Amazon bestseller on climate change. Let's give a rousing Breakfast Club welcome to our speaker of the day, Mr. Greg Wrightstone. Yay!
Thank you so much. Thank you for the introduction. I'm glad to join you and remotely meet each of you virtually. I see we have several authors. The book itself, you might be interested. It rose to top 10 overall bestseller on Amazon. It stayed as a #1 bestseller in several categories for about the first 2 years of its publication, and recently, even just as recently as last week, it was a #1 bestseller in public policy category. So books that were published 3 years ago shouldn't be doing this. So it's been, I wrote it for non-scientists, and I didn't set out to write a best-selling book. As a geologist, I knew that some of what we were being told about climate change was incorrect, and I suspected other things were. And this led to me, it was really a personal search for the truth about climate change. And what I found as I got into it were that we were being told certain things, they were telling us X, and the science that I looked at said Y. And we'll look at some of that as we go through this morning. So again, we've got, and you'll be interested too for your authors. The book was just published 2 months ago in Norwegian. The Korean language version is being published soon, and I'm speaking tomorrow about the Portuguese language version in Brazil tomorrow. So with that, I'm going to share my screen and get started. So the title of the talk is Global Warming, the Cold Hard Facts, and we'll get right into it here. Concerning the climate debate, and yes, Virginia, there is a debate. We also hear of the 97% consensus on climate change. I deal with that in an entire chapter in my book, disputing this 97% consensus. There may well be a majority of scientists that agree that man-made warming is leading to catastrophic effects. There is no disagreement, though, on the following facts. CO2 has been increasing, particularly since the mid-20th century. Nearly all of the CO2 increase is man-made, mostly from fossil fuels, a little bit from cement manufacture, and temperature is rising. We've been in a long-term temperature increase really for more than 300 years that we'll look at here. There is serious disagreement on several issues. Is the increase in temperature that we've seen since the beginning of the 20th century, is it primarily due to increases in greenhouse gases? Or is it primarily due to the same natural forces that have been driving temperatures since the dawn of time? The second big issue here is, are the changes we see of rising temperature and increasing CO2, are they harmful or beneficial? And we'll look into that this morning. This is a CO2 atmospheric levels of CO2 that we see since 1959 as measured at Mauna Loa. So yes, we've been gradually increasing. It's steadily increasing. I've posted on here too the 6 most important climate agreements, and you can see that we've had 6 of these big climate conferences over time, and it hasn't done a daggone thing to stop the increase in CO2. However, as an executive director of the CO2 Coalition, I'm a big proponent of the many benefits of CO2, and we'll see that and take a look at that as we're going forward. Looking at the longer term picture, we see that CO2, this goes back to the year 1751. These are carbon emissions into the atmosphere. And you can see here that really it's been uh, since the middle of the 20th century. It was in that post-World War II economic boom that our friend Sid was in. It was that post-economic World War II economic boom that really started kicking off huge increases in CO2. So as we're going through this, keep in mind that that's about if man's influence and man's emissions were going to influence temperature and the climate, it's in that period that really should be affected. And just FYI, as we go through here, blue, as you see here, will be carbon dioxide or carbon dioxide emissions. Anything you see in red will be temperature, and it'll always be oldest to the left to more modern to the right. And again, what are the sources of man-made carbon dioxide? It's fossil fuel burning for the most part, coal, natural gas, and oil. Interestingly, 5, 6% is from cement manufacturing. If we look at this is a look at 400,000 years of CO2 history going back through time. And you can see the red dot at the top is where we are today. We're actually at about 420 parts per million. The orangish or pinkish color there are the interglacial periods. These are the 10 to 12,000 year periods where the glaciers receded. And we are thankfully in one of those interglacial periods. And you'll see that CO2 levels here increase every time we get into a warming period. And that's because the CO2 levels are driven by the oceans. Warming oceans expel CO2, cold, cooling oceans absorb it. I know it sounds counterintuitive because you think, well, we can dissolve a lot more salt in hot water than we can in cold. That's true, but it's not so for carbon dioxide. And just as an example, if you take a liter bottle of ginger ale, pull it out of your refrigerator and open it, it just goes, put that same liter bottle of ginger ale on your picnic table in the sun in August. And when you open it up, it'll just explode like a volcano. And that's because the CO2 in that ginger ale is being expelled because it's much hotter. But so we just saw where there was a pretty good, looks like a pretty significant increase in CO2. But again, as a geologist, we're going to look at things today in a longer term context. And if we look at today's CO2 levels throughout geologic history, dating back to the Precambrian era, we see that our current levels of CO2, the blue dashed line at the bottom, 400 parts per million, we're some of the lowest CO2 levels in history. And I'll draw your attention to that red dashed line at the bottom. That's what I call the line of death. That's the minimum threshold exist. That's 150 parts per million. We nearly got to that point at the end of the last ice age, thought to be the lowest levels of CO2 in Earth's history, dating back to the Precambrian. And this is a pretty scary chart. This is 140 million years of CO2 CO2 in the atmosphere. And we see a nearly linear decline from 2,500 parts per million down approaching, we got within an eyelash of crossing that line of death at the end of the last ice age, which is geologically speaking in the pretty near recent past. So our 400 parts per million compared to the average over the Earth's history is 2,600 parts per million. So the average throughout Earth's history, 6.5 times what we are today. So if you look at this in the geologic context, a pretty good case can be made to say that we're actually CO2 impoverished. We don't have too much CO2. We don't have enough. And we'll take a look later at the many benefits that this increasing CO2 has on Earth's ecosystems and by context, humanity and the human condition. If we look at, and again, this is red is temperature, blue is carbon dioxide emissions, and this is it's called the Hadkrut-4 data set, and it measures surface temperature globally. Looking at this, it looks like a pretty good correlation between rising CO2 and rising temperature, doesn't it? But again, we're often told too, This is the last decade, the last month, the last year were the hottest ever on record. Well, if your record only goes back 150 or 200, even 300 years, that would be true. We need to put this in the longer term perspective. Uh, but also, if we look at this period from the mid 20th century to today, the majority of that period, we've seen that temperatures were either stable or cooling. We saw there was a 30-year cooling period from the late 40s to the late 70s. Remember, back in the late 70s, everyone was talking about the onset of the new ice age. Um, so if CO2 was going to be driving that, you would think it would be just different. We would have more warming and less cooling or stable temperatures. Uh, and also, if we look at the recent history, we see that there's really been a pretty stable surface temperature. It's called the pause. Uh, and again, we looked at this chart, again, comparing CO2 emissions to temperature. Remember, we said it looks like a pretty good correlation, but I'll remind you that correlation is not causation. When we put this carbon dioxide record into the longer term history, and this is the Central England temperature record, which is the longest thermometer-based temperature record on Earth, and we take a look at this, we find that the warming trend we're in started in the late 17th century, the year 1695 to be exact. So we've been warming in fits and starts for more than 300 years. But yet, carbon dioxide increases would only have enough effect dating back over the last 70 or so years. So we had 250 years of warming that was entirely or nearly entirely naturally driven. But yet we're being asked to believe that that natural warming ceased sometime in the mid 20th century. That's unlikely. Those same processes that have been warming and cooling the planet didn't suddenly cease 70 years ago. Looking back to it tells us a lot, looking back the last 10,000 years to the end of the last ice age. This is called our current interglacial period. We find that there were 9 other great warming periods, very similar to what we are today. Those warming periods, we look at the last several thousand years. What we find, there were 3 previous, we're in the 4th great warming since the rise of the first civilizations. We look back 5,000, 6,000 years, great civilizations rose up. It was called the Bronze Age. And the peak of the Bronze Age, the highest point of the prosperity of the Bronze Age, was the Minoan warm period. The first great empires, the Assyrians, the Babylonians, the Hittites, great civilizations and empires in India and China arose during this period. And then it started cooling. And what we see historically, if we take a look, there's a strong correlation between the rise and fall of temperature and the rise and fall of civilizations. Each of the warming periods, and you're going to hear me say this a lot, it's just opposite of what we're being told. We're being told fear the warming. Oh my God, we can't let it get 1.5 degrees or 2 degrees warmer. Well, if we look back through human history and through geologic time at the temperature, we find that each of these warm periods, warmer than today, experienced great prosperity. Food was bountiful, food was plentiful, great harvests. And the Minoan warm period is a great example. It started cooling, and within about 100-year period or so, all of these great civilizations collapsed. And it was probably because of crop failure, famine, and pestilence that set in, led to the Greek Dark Ages. And then the Roman warm period was the next warming period. Again, great civilizations and empires rose up during this warming period. There's a reason the Romans wore togas. It was really warm. We know it was warmer than today. The Romans were actually growing citrus in the north of England near Hadrian's Wall during this time. And then it started cooling. There are a lot of competing theories as to why the Roman Empire collapsed. But there's a lot of correlation here between the falling temperature, not just with the Roman empires, but empires in India and China also collapsing. Again, you can't feed your subjects, which led to the Dark Ages, a horrific time there. And then the most recent other warming period was the medieval warm period. If you think of the medieval warm period, you think of the high Middle Ages, that's this time. And then we got into the horrors of the most recent cooling period, which was the Little Ice Age. An interesting correlation here were the relationship between the witch hunts of the late Middle Ages and temperature. Again, we talked about the medieval warm period. It was a time of prosperity and great harvest. Food was bountiful. Life was good. If Craig was he was Emperor Craig in a warm period, he had it pretty good. His subjects were fat and happy. He could feed them. But it started cooling. And in about the 13th century, mid 13th century, it started cooling. Crops started failing. Famine set in. Pestilence, they had diseases spread, and they blamed it on weather causing witches. And in the 14th, 15th century, the Pope actually issued a papal bull that stated that yes, there are weather causing witches, and if you find them, you need to kill them. Well, and they did with a vengeance. And over several centuries during this period, some 40 to 50,000 supposed witches were killed, most of them burned at the stake, elderly women living on the fringe of medieval society, people falsely accused of course, falsely accused. And it really is, witch hunts really didn't end until it started warming up, coming into our modern warming period. So this is a chart here of the number of witches killed per decade on the top, and the months of extremely cold temperature, just relating the correlation between the witch hunts and the witches that were killed were being blamed by crop failures. And again, it's just opposite of what we're being told. We're being told that famine and crop failure will be caused by warming temperatures, where human history and temperature history tells us it has just been the opposite. We'll take a look here at some of what I call the climate apocalypse events. You've seen them, you've heard of them. It's hard to miss them. Our media and government sources, floods, droughts, everything from poison ivy increases, which actually is true. And that's another story, because CO2 fertilization will cause all plants to benefit, including poison ivy. But we've been told it's too hot. We've just been told that the cold that we saw in February was due to climate change. Too much snow, not enough snow. Let's take a look at some of these. So what I do is I live in the real world, and I look at what's actually happening today. Much of what you hear in the media are predictions of what may happen or may not happen 30, 50, or 80 years in the future based on climate models that, as it turns out, can't model climate all that well. So I look at actual historic data. These are the things that H.L. Mencken called his hobgoblins of alarm. Again, these predictions that we hear, all of us have heard, are based on climate models. How well do they model climate? The red line here, there were 102 climate model runs that were run here. This is by John Christie from the University of Alabama in Huntsville. He compared that to actual temperature. And according to him, the models that are used from all these 102, there was actually one that turned out to be pretty close, and that was the Russian model. But of all those climate models, it was predicting and modeling 2.5 to 3 times too much warming as what actual temperatures were measured. And again, one of the things I get in here, it angers me. One of the things that I found as I was researching this, or it's really an abuse of the scientific process, that some of the scientists that come up with these things have a preordained conclusion and then torture the data and torture the facts to fit their preconceived conditions. That's not how science should work. Science should be, we take a look at the data and then come up to our conclusions based on this. You may have seen there was a UN report released. I'm going to show you two examples, just two, of how you're being told one thing and the facts tell us something else. There's this report in 2019. UN reported that there were 1 million species that could go extinct over the next several decades. Well, what does that mean? If you're going to have 1 million species go extinct over several decades, that means you have to have 25,000 to 30,000 species go extinct per year. So this is the chart. This was, again, a UN report that was issued, and this is the chart they included. It looks pretty scary, doesn't it? Oh my God, extinctions are just skyrocketing, and it's going to lead to the next sixth great extinction event. But take a look at this chart. It goes back to the year 1500. There's only 1 point per decade. So they averaged extinctions per century. And I looked at that, my alarm bell started going off. So I said, I'm going to look at this. I went back and took a look at the same data that they looked at. This is called it's from the Red List. You can Google Red List to find that's, everybody uses the IUCN Red List for if you're concerned about extinctions or endangered species. So I went back, instead of looking at it on a century by century basis, I took a look at it decade by decade. These are extinctions by decade going back to 1500. Oh, and what do we see? We see that extinctions peaked in the late 1800s and early 1900s. And they've been in decline ever since. Take a better look at what happened since 1870, and you see that extinctions have actually been in significant decline. Now, remember I said that it would take 25,000 to 30,000 extinctions per year to get to their 1 million extinction mark. You know what it's been for the last 40 years? Okay, not 2,000, not 200, 2 species going extinct per year. And they want you to believe, they'll say, it's going to get to 25,000 pretty soon. No, it's not. No, it's not. This UN report actually should have concluded that we, the human population, as a species, is doing a really, really, really good job protecting our endangered species. And that's not what they concluded. The data that they actually used did not support the contention of this looming next great sixth extinction event. The other thing we hear a lot about are fires. If you're close to it and you're in California, you're close to it. Yes, we had a bad fire year last year, but we need to put these events in the longer term perspective. And if we look at this, and I should have included the California long-term data, and I didn't have 2020 in there. But the fourth National Climate Assessment focused on fire in the Western United States. This is the chart they used to support their contention that fires were increasing significantly in the United States. This is acres burned. Interestingly, they didn't list a source to this chart. They just listed this. And I looked at it and I said, boy, where's that from? So I went back and I looked at my data that's in my book. This is what it is. They cherry picked, instead of using the data that goes back to 1928 for the National Climate Assessment, they took that period from 1984 to present. And yes, has the area burned been increasing? Yes, very slightly. But we see that area burned in the United States was falling dramatically just as CO2 was increasing. Looking at this chart, the red numbers on this chart, without that, we see that the area burned has decreased. We're at less than 25% of area burned per year in the United States than what it has been historically, dating back to the early 20th century. And why would they just select that one area and then blow it up and exaggerate it? And again, let's take a look back here. This is that chart that they used to support their contention of dangerous fire increases, and this is the actual chart showing all the data. This is the number of fires in the United States, again showing a significant decline. through dating back to the early 20th century, just as CO2 was rising. We'll talk about why that might be in just a moment. This was the largest study of its kind, looking globally to the beginning of the 20th century. This is global area burned. And again, this was by Yang. And he says, our results suggest a notable declining rate of area burned globally. Well, why is that? According to this study by the Canadian Fire Service, Flanagan and et al., they stated, we believe that global warming since 1850 may have triggered decreases in fire frequency. That's right, global warming's triggering decreases. It's just opposite. Again, it's counterintuitive. We know, though, that there are two reasons that fires may be declining, and that's because rising temperatures likely lead to more water vapor, more moisture, and a slight increase in precipitation. So that increase in precipitation, again, dampens fires. The other factor here is the CO2 fertilization effect. As CO2 increases, plants need less water. So in California, if we look at your fires there, the Sierra Nevada Conservancy reports that there are 4 to 5 times too many trees per acre in the Sierra Nevadas. And think what that means. It's not just that there's more fuel to burn. That's important. But now you've got dry areas. You've got 4 to 5 times as many trees. The second greatest effect on soil moisture content is what the plants and the trees draw out of the soil. So now we got 4 to 5 times too many trees competing for that same scarce soil moisture content. So it's adding to the aridity. You got too much fuel, you got too much increased aridity from too many trees. But again, the CO2 fertilization means that these plants and these trees can survive with much less water. They're sucking less water out of the ground. So that's these two things combined are probably the reason for decreasing fire. The other increase here that's stunning, I call this the greatest untold story of the late 20th and early 21st century, is the CO2 fertilization effect that's greening our planet. This is a study from NASA, and if you don't believe me, just Google NASA and greening, those two words, NASA and greening. This study by NASA concluded that up to 50% of the Earth's surface is what they call greening. In other words, vegetation's increasing. Less than 4%, according to NASA, is what they call browning. In other words, loss of vegetation. Well, I'll tell you, that's a pretty good trade-off. I'd take that any day of the week. And what this is doing is it's showing, we're being told the deserts are expanding. Desertification is occurring. Just the opposite of what we're being told is actually occurring. Areas throughout the world, arid areas are greening. Australia, India, probably the greatest place we can see this is the Southern Sahara. It's called the Sahel. That's turning into a lush grassland. People are moving back there that haven't lived there in more than 1,000 years. Animals are moving back in. Gazelles, even amphibians are moving into this former desert area. And we're seeing this around the world. It's the greening. It's a combination of slight increase in precipitation, but it's thought to be mainly due to the ability of plants to survive in arid conditions because of increasing CO2. We also see the CO2 increase is fueling not just plant growth, but crop growth. Dr. Craig Idso, who's a member of our CO2 coalition, one of the experts in CO2 and plant life. These are laboratory studies. He looked at what a 300 part per million increase in CO2 would do to these crops. And he looked at 90 of the top crops that are consumed around the world. And he found that it would increase crop growth by 46% increase in biomass. That's a good story. That's a huge, huge untold story that we're not hearing about. we can feed the hungry. With an increasing population, we need more food, and CO2 increase can do it. It is doing it. And there's a reason too. You might, your marijuana growers in California, I haven't seen any, I know they're doing it in Colorado. They're pumping, actually taking the CO2 from breweries and pumping it directly into the marijuana greenhouses to fuel marijuana growth. And we see too that, again, this CO2 fertilization effect combined with increasing temperature is leading to record-setting crop growth year after year after year. And just think about what increasing temperature will do to crops. We have longer growing seasons in the temperate regions. Killing frosts stop earlier in the spring and arrive later in the fall. We can have more plantings. And then the CO2 increase is driving increasing plant growth. And this is backed up. This is from the UN's Food and Agricultural Report. We see we continue to increase and break records year after year after year around the world. We're also being told, aren't we, that oh no, it's going to, if the warming continues, we're going to be in drought conditions. Well, is that the case? Let's take a look at what's happened over the last 40 years. And this is a global, it's called the Global Integrated Drought Monitoring and Prediction. They looked at droughts around the world and the drought conditions globally. And we see here, instead of increasing droughts, they're actually decreasing. That's a good thing. And I took a look here. This was a study looking at the most severe droughts of the 20th century. This is looking at 20-year increments that we're looking at. And again, we've seen these terrible droughts. And we looked at 20-year increments because the severe droughts tend to last more than 10 years. They go, these are decades, some of these that last. Well, we're not increasing. We see the temperatures increasing and CO2 increasing, yet droughts are decreasing, and by a lot. Again, just opposite of what we're being told. This is the largest, again, we're being told too, and we hear this a lot. This is stated as a fact that global warming is going to lead to huge number of deaths. Is that the case? This is the largest study of its kind looking at temperature-related deaths around the world. They looked at 74 million temperature-related deaths around the world from 14 different countries, including warm weather and cold weather countries and temperate countries. And their conclusion was that cold-related deaths cause 20 times as many deaths as does heat. 20 times. Now, we've got another study in my book that I capture. They looked at England and Wales. That study concluded, and Australia, that study concluded that that it was 15 times as many cold-related deaths as due to heat. Whatever it is, it's a lot more people due to cold than due to heat. A very, very good conclusion here is that global warming will save lives. Because of that, you're going to have fewer deaths due to cold. We're also told that extreme weather is increasing, and it's also going to impact the situation in the United States. But yet we see that when we take a look at this is extreme weather-related deaths in the United States. There's been a significant understatement, a 98% decline in extreme weather-related deaths since early 20th century. Now, again, a lot of that has to do with better prediction of hurricanes coming, tornadoes, but nonetheless, this flies in the face of what we're being told about increasing extreme weather-related deaths. We're also being told that hurricanes are increasing. We had several last year. But again, you can't look at one season in its context. Let's take a look here back to 1850. It's hard to measure hurricanes long-term because some of these hurricanes back in the past, in the pre-satellite era, they could rise up and dissipate and no one would know it. But according to NOAA, They use this chart, and these are landfalling hurricanes in the United States, because according to NOAA, it's hard to miss a hurricane that makes landfall. So they're pretty confident they've cataloged all the hurricanes. And what do we find here? Landfalling hurricanes have been in decline. They're certainly not increasing. And we also look, one of the top hurricane experts at NOAA, a fellow by the name of Christopher Landsea. Isn't that a great name for if you're a hurricane guy working at NOAA, your last name is Landsea? Almost as good as a geologist named Wrightstone, I would think. But according to Christopher Landsea, he took a look at whether or not hurricane intensity is increasing, and he concluded that additional warming may increase intensity of hurricanes by 1%. Now, okay, let's say he's correct. I don't think if you were in Katrina, you could tell the difference between 180 miles per hour and 182 miles per hour, 183. It's still big. So that's not backed up by the data. In conclusion here, I want to say that policies to slow CO2 emissions are based on flawed climate computer models that exaggerate warming by factors of 2 or 3, and that overall carbon dioxide's an overall benefit. So what we're trying to do, these costly mitigation schemes that are cost, some estimates of $100 trillion for the Green New Deal and its cost. And the conclusion in my book is that we should have the courage to do nothing about CO2 emissions. What is being proposed now is what I consider a solution in search of a problem. And I'll leave you with this. We hear about polar bears. A decade or 2 decades, the last 10, 20 years ago, the polar bear was the iconic symbol of global warming. We don't hear much about it anymore, do we? Why is that? Because everyone recognizes today polar bear population is expanding and actually expanding to dangerous levels if you live within the Arctic Circle. So with that, I'm going to stop sharing and take some questions.
Well, first of all, thanks, Greg. You had some really interesting points, and I love the graphics. Let's go ahead and open it for questions. Who would like to have a question? Betty?
Hi, thank you for your presentation, and the slides were very, very interesting. It was an eye-opener. 2 questions. Number one, your hurricane data, I think went to 2004, if I'm not correct, and did not include obviously 2020. So that's one question. The other question would be, what about water rising due to, quote, maybe global warming in California and where I live? So I don't know if you mentioned that. So thank you.
Yeah, I'm stressed for time. I have an updated landfalling hurricane. And yes, we did, periodically, we do see, in terms of hurricanes, there are some seasons that are bigger than others. But again, we can't look at 2020 and just say, you have to put that in the long-term context of it's centuries of data. There's another that I have here in my book there's a Mexican, University of Mexico conclusion for Atlantic hurricanes going back to 1750 that they did. And their conclusion was the same, that actually hurricanes have been in decline. And as for sea level rise, it's risen about 7 inches or so. We see that over the last, since the 20th century, which is not alarming. And there are allegations of increase. We don't see, looking at the long-term data from tide gauges, which is the best long-term measurement of sea level rise. It's pretty conclusive that sea level is not accelerating. We started seeing sea level rise about in the early to mid 19th century, in the 1800s. It had been warming since 1695, but it took until the mid 1800s for it to warm enough that summer ice loss exceeded winter ice accumulation, which is what you need for glaciers to recede, and that's what fuels sea level rise. So we see a correlation between glacial retreat and sea level rise, but neither of those things, glacial retreat or sea level rise, based on long-term data, we've not seen an acceleration linked to CO2 increases.